Good afternoon, everybody. Welcome to this lunch talk. Maybe you have already had lunch or you will have lunch now in the meantime. And I hope that my talk will be well digestible. It's about the data and information backbone of circular economy, and more specifically about digital product passports. Okay, let's move forward. So this talk, I am Karel van Akker, Professor of Circular Economy in the VCCM Core Lab of Flanders Make and at KU Leuven. And I made this talk together with Giovanna Sovi, who is a business developer for the Core Lab, and René Reich in my group. First of all, I would like to go a little bit into the context of this data backbone and digital product passports and say some words about what circular economy is, since that's important to know what kind of information do we want to have at the end of the day. And if you look at a proper definition of circular economy, which is drafted these days by the OECD and the United Nations, it's said that it is an economy where the value of materials in the economy is maximized. And that value is also maintained as long as possible in the economy. It also means that the input of materials and the consumption of materials, specifically virgin materials then, is minimized. And thirdly, that waste is also minimized and environmental impacts reduced. It's quite important to take that into account, since it will also determine what kind of information we need to underpin the circular economy. So value of materials here is understood to encompass the value of society as a whole. Input of materials is referring to the preservation of natural assets, and consumption is more related to resource efficiency. And we all deal with that in companies and as individuals. And then finally, it should be looked at all stages of the life cycle. And if we want to know more about what we have to measure within the circular economy, we first have to look to the product cycle, where recycling, reuse, repair, rethinking is used as strategies to keep materials into the economy or into this cycle. But we also have to know how many new resources, think of the second bullet in the definition, and how much waste is generated, the third bullet in the definition. And finally, we also want to know things about the impact of what we do in the circular economy, the impact on environment, impact, of course, on economy as well, and the impact on society at large. Often the circular economy is defined by the strategies we can follow to realize a circular economy, strategies which most people think of recycling, but it's also about repurposing, remanufacturing, refurbishing, repair, until rethinking, the so-called R strategies. And we follow these strategies at several levels, actually. Many people, or most people, think of the level of products and services. But circular economy comes in much more levels. It's also about the business models level. It's also about the level of production and technologies of whole companies, of networks and value chains, sectors in economy. So we have to look at circular economy in all these layers and their interaction with environment and society. Now, circular economy is very much on the agenda of the European Commission and of other governmental levels. And the Commission came with the Circular Economy Action Plan, which is actually describing what circular economy means and what future directives they will change or install for this circular economy. So they see actually circular economy mainly as a means to achieve climate and biodiversity targets, not as a goal on itself, but more as a means. And it focuses on these 5 product groups. On the plan focuses on electronics and ICT, textiles, furniture, and high impact intermediary products. And already in that plan, which is already, well, the first version is already 4 years old, but the second one is 1.5 years old. Already in that plan, there is a lot of attention towards digitalization of circular economy by these so-called digital product passports. So let's now dive into more detail of these digital product passports. What are they? What do they want to achieve with that, and so forth. So if we look in what is said in the recent Ecodesign for Sustainable Products regulation, it's stated boldly that digital product passports will be the norm for all products that are regulated on that directive in the future. And why, or how, first of all, how will they do that? And by tagging, by identifying and linking to data that is relevant to the circularity and sustainability. So it's vague, but we first of all have to think of, what do they mean with relevant to be relevant to circularity and sustainability? The goal that they want to achieve is mainly improving environmental performance, prolonging product lifetime, boosting efficiency of products, using secondary materials, and lowering the need of primary materials, and of course, also securing supply, reducing strategic dependencies, saving costs. These are actually the goals that they want to achieve with these product passports. It's also mentioned that it is a means to follow up better on the presence of substances of concern. I will not talk about that here in this talk. So there are some initiatives that are more specific. So digital product passports are being built today, mainly for batteries and also in the construction sector. And it's also mentioned in the future plans, Environment Action Plan of the Commission. So what do we need then to digitalize actually the information we need to boost the circular economy? There are many challenges in there. We first of all have to capture data. You can capture data by tagging assets in the communication about sustainable products. You could also attach RFID. You could introduce blockchains to send this information to systems. So then the information system is important as well. How will that be conceived? Will there be a data space, one overall data space for digital product passports, or will there different data spaces, one for batteries, one for construction, one for textile, and so forth? How will it connect to digital twins? Very important, we also have to better define what indicators exactly do we want to have. What will help companies, what will help policymakers to incentivize circular economy, to go to the right business models that support circular economy, and so forth. And of course, if you talk about data and information systems and so forth, there will also be quite some legal issues. The protection of the actors and their properties is also very much important in these developments. So if we simplify a little bit, we can say that digital product passports will come at several levels. The most obvious one is the level of the material, but it will also come on the level of components, of products, and of systems. A system could be, for example, mobility, mobility by cars, trains, and so forth. A product to support that mobility is, for example, in this picture, a car. A component can be an engine. A material could be, for example, a foamed polyurethane within a part of the car. So that's important to understand, that digital product passports is not something that only will be attached to a product. It will also be attached to components, to the materials used, and it will also be used for following up on the transition towards circular economy in systems. So these digital product passports, it's quite small, but they mainly deal with cradle to gate data of these different levels: materials, components, products, and systems, composing of information of who is active in the value chain, product and producers identifiers, technical specifications, certainly at component and product level. How are these products composed? How can they be manufactured? How can they be repaired, and so forth? And of course, also composition of materials. But we also think that gate to cradle data is important as well. In a circular economy, you want to maintain resources into the society as long as possible. So you have to know something about usage of the product and the components, of service history, of end-of-life performance of these materials. So, and that will be used, and that will not be all open data, but it will be open for the relevant partners within the value chain, governmental actors, public bodies, companies, and so forth. And it should cover all the phases in the life cycle of materials, components, and products, so that we can know better what the effect is and what the possibilities are for reusing, repair, refurbishing, recycling, and so forth. So we have to make a connection between systems and products as well, and we have to make also a connection between these 4 levels at which it will act. So where are we now today? So these digital product passports, yeah, there is much said about it, but it's really it's really, yeah, still at its initiation phase. So there is a lot of studies on how should it look like, what data flows should be followed, and so forth. But the good news is that some bits and pieces that we need for building up these product passports are already in place. But on the other hand, most of these pieces relate to the system level on the one hand and the material level on the other hand. There's not much in place for component levels or product levels. There is also a general lack of data that's typical for that, and I will show that later on. So yeah, there is really still a need for much better structuring of data, for linking data, and for the right protocols. So I will now go quickly over some parts of this information and bits and pieces. I forgot to say in the beginning, but I will say it now, that at the meantime you can add your questions at the Q&A button. So I will spend some minutes on answering questions afterwards. So please do use the Q&A button for that. So at the system level, We have, for example, quite some work done in the CE Center for the Flemish government on following up material flows in Flanders and deriving circularity indicators. So data there is mainly data that can be found in official statistics, but you have to understand that a lot of these data are just economic data and not data about physical flows of materials and products. And to give you one example for the mobility system, key is that we start from the demand side for what is actually the need for mobility. And the need for mobility are kilometers traveled, which is in Flanders quite stable and mostly performed with the aid of cars. So at the system level, if you look at cars, then important there is, and that might sound new to you, but important there for the circular economy is to understand how intensively cars are used. And we see that actually the intensity of use is going down, and how long they are used. And that is quite stable, how long in terms of mileage here. What is better known is then what happens with end of life of cars, which is very well done. We recycle more than 95% of the cars and of the tires. Second level that is also very well known, that's about the materials. There are a lot of studies of material flows, of their impacts to the environment via life cycle assessments, for example. This is one example, and so the value chain of the materials that are used for making permanent magnets in electromotors. So we did a study to see what is now what is the impact of indirect recycling, so recycling all the elements, alloying elements, or recycling the alloy itself, or reusing, and then you see that the indirect recycling has the highest impacts. Data there are very much case specific, so it's quite data intensive, and often it's just related to some producers within a project that are willing to share data to that. So the two other levels, component and product level, are not that well known. So at the component level, there you also have to look not only to reusing and recycling the materials, but also the components of themselves. Can they be recycled, and how do they contribute to the circular economy? So that's the case of a washing machine, in which all these flows are followed up of materials within components. In this case, we can set up a scheme of all the flows of the materials and the components and come to a kind of score, which is typical, 15%. It's still quite low. That means that there is an enormous room for improving to better reusing and recycling materials and components in this case. Another aspect of it, of the component level, is that in digital product passports, we also want to know what remanufacturing ability is. And so can a product be demanufactured? Can it be can it be disassembled? So an example is of a colleague of mine, also partner within the VCCM core lab, that Chef Peters, is how easily you can disassemble a component out of a car, for example, or a washing machine, and so forth. There are, that's the EDIM methodology. I will not go into detail, but of course, that can be used for helping repairs to disassemble the part that has to be repaired. It can also help OEMs to improve their designs. It can also help, of course, authorities to set better incentives and criteria for circular economy. And finally, the product phase. What we have to do there is to follow up on the stock of these products and the flows of these products. This is, for example, a stock flow scheme for cars, the car fleet within Flanders. And in between all these stocks and the in-use stocks and stock of secondary materials, stock of reusable components and so forth, the flows can be influenced by circular economy strategies, by reusing, for example, incentives for reusing, incentives for sharing cars and so forth. And you can then calculate with this kind of stock flow modeling, which is also quite data intensive. You can calculate then what the impact is. I will not dwell on this one. What the impact is on the total materials demand. So the green one, the green line, is the case in which several circular economy strategies are followed for a low increase of electric vehicles on the market towards a high increase of electric vehicles on the markets, which demands quite some more materials in the beginning period, and so forth. So that's a new trend, and for that kind of calculations, we need to know lifetimes of products. We need to know intensity of use and so forth. So I come to some conclusions. What I wanted to show is, well, first of all, digital product passports is a concept today that is very much pushed forward by the European Commission. It will become legal. In what form, that it's not sure yet, but today, it's more specified and will first come operational for batteries, construction, and in a later stage for textiles. But of course, there are also many hurdles still. There are many stakeholders involved in digital product passports development, and of course in making that operational. There are different needs. The need of a company is different from the need of a governmental agency. The data requirements are not that clear. It's quite clear for understanding better recycling potential, but if we want to know more about the potential of reusing, of remanufacturing and things like that, it's not that easy to find the right data to underpin that kind of information that you want to get out of digital product passports. Of course, it also has to be connected with physical products. Also, that is still open. Will that be RFID or just a label or something else? And there is also a risk that there is a fragmentation in different types of digital product passports, one for the batteries, one for the construction, and so forth, which would be also a pity, since in the circular economy there are a lot of connections between the different sectors as well. So a dismantled component of, let's say, a washing machine maybe could be used in a completely different context. But there are also many opportunities. First of all, it's meant to boost circular economy strategies, but it will also give more insight in the market and the use of products. I do believe that it is a big opportunity for developing new business models and specifically to estimate better the risks associated to that. it will help to make value chains much more transparent, which is asked for by many clients as well. Security of supply and resource efficiency, that's of course also a goal to attain with the aid of digital product passports. And it could also be used to have better verified carbon footprints of value chains and to follow up on the chemicals of concern. So I hope I gave you a small overview of where we are with the digital product passports, what the concept is, what we know about it, and where we are today. And I will be happy to answer some questions now if there are some. So I will stop sharing my screen so that you can just see me. And I'm going to the Q&A. So are there any questions? I don't see a lot of questions now. Sorry, yeah. So the first question about building passports and DPPs, and that's very much the same. So the idea of a building passport exactly is to know better what material and what component is used where in a building, and what you get when you dismantle a building, which is the basis of a digital product passport. Data available at the system level. I hope that I gave some examples with what we did within the CE center. So that's about the total amount of products within the system, the total amount of cars, and how that can evolve based on on strategies you follow for circular economy. So, for example, that's the level to have insights in the effects of car sharing, for example. So sharing business model, it's very hard to find out what the real effect is on resource consumption and on circularity, but that's the level where we can see that. There is a question about the lead in content and structuring. That's very much European Commission led for at this moment. They gave a mandate to, for example, the battery alliance for the batteries. So stakeholders will certainly be involved. There are also several European projects with companies and universities involved, which are developing or studying what should be in the product passport, but the final decisions will be at a political level. Sorry, I have to read a bit the questions, and I cannot answer. I just want, there are quite some questions about data and what data should be in there. And of course, we have to make a difference between what data is on one hand and what information is on the other hand. And both are not 100% clear today. And so the information that's more my cup of tea, let's say, what is circular economy about? What do we need to know to, to step further into the right direction, let's say, and what data do we need? Data is more related to the product. It's related to composition, for example, of the product, as well as history of how it's made, as well as instructions of how things can be disassembled, and so forth. So it can be indeed, it can be coupled with some models as well. And yeah, I think AI will certainly be needed to interpret all this data. I mean, since that will be a huge amount of data, I also think that, and I forgot to say that, but all these things will not be built up from scratch, and they will use all data that is already reported for other purposes, such as reach, for example, or in the automotive industry, the IMDS and things like that. And I think AI will also be needed to extract the right data that we will need for making product passports. Prototypes are not yet active here. It's very much at a conceptual level, except for the bits and pieces I tried to understand. Yeah. So it's a good question that's how you can prepare yourself already. That's not easy to say. It's a bit a chicken and egg question. That I think you can prepare yourself by trying to make your own materials flows, components flows, and so forth within the boundaries of the company, to interact also with suppliers on that, to try to derive your own circularity indicators. But on the other hand, it's not for granted that this is the kind of things that finally also will end up in a digital product passport. So in that sense, it's a bit a chicken and egg question. Yeah, I was looking at a last question about how data, if I interpret the question well, it's about how much data is needed and where it will come from and how it will flow, and so forth. Yeah, indeed, this has to be made clear much better in the future. Again, so it's a huge. It will be a huge effort and system that mainly will be based on existing data. There is also danger in there, since if you only use existing data, you will you will not go further than the traditional or the conventional way of interpreting circular economy, that is recycling better, for example. So that there is a danger in there to stick to existing data. So we will need to add some data to that as well, about, as I said, lifetimes, for example, of products. And that has to be regulated very well. But I often make the comparison with the health sector, where a lot of data about your personal health is known by combining all kind of information from different medicines and hospitals and so forth. So there, actually, it's an example of how it can work and how it also can work in a safe constellation, since you cannot see all this, or somebody else cannot see all this data. Okay, I think we have to finish here, if I understand it well. I thank you very much for your attendance and for your questions, and I'm always happy for trying to answer personal questions as well. And I hope that the presentation will be also published or sent to the attendees later on. So thank you very much, and see you on the next occasion.